Right. Good afternoon, everybody. It's great to hear the discussion going so well already and networking going, but we're starting on the first session of the Global Ocean Acidification Observing Network workshop. And so welcome, everyone. This is the second international workshop on this, and I welcome you all here. We're going to have 2.5 days of really productive science and discussion and networking and planning for the future. So I would like to thank all the funders, you can see them up here, and all the organisers, both within the UK, locally within St Andrews, and the wider community. And I know the NOAA played a big role in helping organise this as well. So, with that and all the thanks done, I'd like to welcome the first speaker, who's Dr. Phil Williamson. You will all have had dozens of emails from him by now. He's from the University of East Anglia, and he's one of our cherished national heritages, because he is absolutely excellent at coordinating science programs, and just you being here is part of Phil's excellence. So he also is the science coordinator for the UK Ocean Acidification Research Programme. Phil, thank you.
Thank you very much, Carol, for that introduction, and it's obviously a great pleasure to be here. And although Carol has sung my praises, there are some things that unfortunately I do make mistakes, and one of them was actually that for our sponsors, they changed their logos during the course of the last 2 or 3 weeks, so that on the printed programme and on some of the banners, then some of our logos, that's a little bit different from what you might have seen, but however, we appreciate their support. My role is actually, this is a joint session between the UK programme and the international workshop, so I'm going to be covering some of the aspects from the UK programme and some of them from an introduction to the international workshop. And at the beginning of the week, we actually had a welcome from Professor David Patterson, who told us that St Andrews was the oldest university in Scotland, 600 years old. It's celebrating its anniversary this year, and that it was the third oldest in the United Kingdom. So that's quite a tradition to live up to. As I say, my title is very general, and I will be dipping into lots of other things, but I'd first like to thank my co-organisers for this meeting, particularly Libby Jewett and Jeremy Mathis. Their names are on there. But there's also an organising committee that worked very hard and really provided the inspiration, and some of them also helped to provide the money, so that their names are up behind me. You'll also find them in the booklet, and they're also online. So if I don't get a chance to give them their due credit at the end, then at least they've started off at the beginning. And I'm going to start off at the beginning of a slide that hasn't been shown, but in some ways is sort of the scale of the problem. This is part of the science to policy bit, and behind me you'll see the carbon emissions and what we've been doing on the planet, and the various projections that are being used for the next IPCC, Intergovernmental Panel on Climate Change. And although the overriding concern about carbon dioxide emissions is in terms of climate change, there is also, as I don't need to point out to this audience, that carbon dioxide emissions are the cause of ocean acidification, or the primary cause, and therefore if one can achieve something quite remarkable, changing the red curve behind me, which is the track that we're on or slightly exceeding, within the next 10 years, somehow or another, governments of the world and peoples of the world, if we want to avoid dangerous climate change and also dangerous ocean acidification. Now, for the UK programme, I dipped into some of the slides that I've been using over the last 3 years, and this was one of them, and it showed that the reason why there is interest from the governments and from the funders in the programme, they put money into the programme, but they also want to see something out of it, and that the outputs are pretty important. And that from behind me you'll see The aims, the UK Ocean Acidification Research Programme, aims to increase understanding of processes, reduce uncertainties in predicting impacts, and improve policy advice. Well, there's actually one thing that we got wrong there and got badly wrong, and I should have known, should have avoided it. Do not say that you're going to reduce uncertainties, because it is sometimes uncertainties increase. And the reason why I've been caught before on this, about 20 years or so ago, I worked for IGBP, and I produced a booklet that was called Reducing Uncertainties. And what happened after producing that booklet, we found out about all sorts of processes and biogeochemistry, and the reason why the world was very uncertain, and that made the implications for climate change are still being thought through now, but at least we did the research and found out. But for other ways that uncertainties can increase, even the most simple, basic arithmetic, we've got to throw out of the window, in that we don't know whether things add up additively or synergistically or antagonistically. That if you put two things together, you don't one and one don't necessarily, they can sometimes be more than two, sometimes be less than two, or they might be exactly two, but we don't know. And we're still working out those things. And in having put multiple stressors up, that was one of the themes that came out of a breakout discussion session as we had yesterday afternoon. We had reports of from this morning, multiple stressors. Really, really important. CO2 does not act on its own. It's warming there, and a whole lot of things. Now, for this particular meeting, I've been under multiple stressors, and it's whether or not 1 and 1 make 2 for the purposes of this meeting. And I hope that in terms of outputs and the added value, that 1 and 1 will make note 3, 4, or 5. However, we will wait to see. I should not prejudge. And let's see, for the UK programme, there's been, I think, around 100 people participating in the meeting up till now. Not everyone from the UK programme has been involved. As you'll see from the map, they're widely scattered, and some of them have been on holiday now. We can also see from the map where we are in St Andrews in the north. And I think the numbers are about right for where people have come from the various institutions, so that it is teamwork for the UK programme, and that's been exemplified in the way that the teams and the groups have been brought together, and they were brought together at the start of the programme 3 years ago by a deliberate attempt to say, well, what is it that we need to find out, to define the objectives. You'll see them up on the screen. I'm not going to read them through. Anyone can look at these at leisure subsequently, but these are the particular areas that the programme is going to focus on. And what we've done then is built up research teams in those areas, and they've been reporting their results in the last few days. And that some of them you'll have heard and met, and some of them are still here. So those are the way that the programme was structured, but it certainly was not structured as a series of little silos and balls sitting out on their own. It was structured so that there would be very intense internal connections and communications, but also not shown there, we also had the emphasis on the external connections and communications. And just to look at for a quick flip back in time and a little bit for the future, that the main UK programme is actually coming to an end, and that this is our final annual science meeting. We might have another meeting next year, but it took quite a couple of years or so to get it going in the planning stage. We had an intense fieldwork programme, as you'll have heard. We had our previous annual science meetings at Exeter last year and Cambridge the year beforehand. But having mentioned the external context, there was 2 very important meetings, and there have been lots and lots of very important meetings, but I'm just going to highlight 2 of them. Right at the start of our programme, we were invited to Germany by UKOA and BioAcid. We had a joint meeting with them. That was very influential and very important for the UK community. And then last year, there was the US-hosted meeting that many of you went to at Monterey, the third ocean and high CO2 world. And during the lifetime of the programme, then there's been the European UKOA programme, many of you know about it. There's been the German BioAcid Phase 1, Phase 2, MedSea programme, a whole lot of others. I haven't got room on that slide, but now I'm going to mention the development of the Global Ocean Acidification Observing Network. It's a little bit hard to say, well, where did it come from and how long is it? But it's been in people's minds, I think, since at least 2008, 2009, because it featured in a major Ocean OBS meeting in 2009, and there has been discussion along these lines of the need, and various people here have been involved in that. And the way in which it came together, you might be seeing the slide again later on, but these are some of the main bodies and some of the dates of which the thoughts came, well, the international community really needs to get its act together and to make sure that we're going into this and making sure that the data is comparable, and as far as possible that we're able to learn from each other and take it forward together. So those are some of the background to the first Global Ocean Acidification Observing Network meeting that was held in Seattle last year. There are reports from that available on the table. You should have had them by email as well. That's a pretty important document. If you haven't read it yet, you've got tonight to do so, and then you'll be fully aware of it for tomorrow morning. Now, there's various acronyms and initials there, and there'll be a few more. That's the name. We're debating whether or not to have this and ecosystem response, but now it is implicit that it isn't just the ocean acidification, it is and its impacts, and so that is implicit in the title of the observing network. As I say, that's the website that's on there that probably many of you are already familiar with and can get various documents from there. Above at the top there are the sponsors for the first Seattle meeting. Here again are some of those sponsors and some of those organizations, and these are the many bodies. These are just some of them, of the main, taking forward the direction and the governance and the ideas and the connections. Different bodies, different organizations have different roles, as you can see there. Some you'll be familiar with, some you might not know about, but you'll be hearing about some of these this afternoon. And in the background, there's then a second tier of some of those bodies have got parent bodies or sponsoring bodies or links. Some of those are governmental, some of those are intergovernmental. One of these diagrams is in your booklet, the other one isn't. We'll be evolving, discussing. It's one of the topics for Friday afternoon. So just have a quick glance down there. If you recognize some, fine. If not, you'll find out about them later on. Now I'm going to this is the interval time. I'm going to take a break. We're going to watch a movie. Actually, you're not. This was a movie that came out, I think, just before one of those meetings early on in 2010. And I was very impressed by this. I like the different levels of reality and going in and out of dreams, and you're not quite sure where you are and whether you're going to get out in time. So I use this sometimes as an aid to communication of the different levels that we operate in. And so for this morning and for the first 2 days of the week, we were at level 4. The ocean acidification scientists were talking to ocean acidification scientists. It was an internal one, and if other people in the audience didn't understand it, if they didn't know what TIC or DIC or TA was, well, that's just their bad luck. Sorry, but you weren't part of the inside community. Now, this afternoon, we're going to be much wider, and if you don't understand anything, then that's the speaker's fault, and you really must say so and let it be known. So there is a problem, even in ocean acidification scientists talking to other scientists, because they've got different languages. And then it gets that much harder for talking to governments, funders, informed citizens. It gets harder still with the general public. But this was a slide. It only got flashed on. It was yesterday morning, I think. Toby Tyrrell, are you here? I think it was Jeremy Young who showed it. But we were expected to absorb the information from that, flashed on the screen. Right, okay, you can take it all in. You know what it all means. Well, that was one that was actually that slide's been around for a couple of years, and I looked at it and made it a little bit simpler. And this is for the scientists, for those who can find out what the words mean and understand things. But even that, it's quite a lot to take in. I'm just flashing it up. You're having a glance at it. Seems to make sense. There's a lot of information there. Now, to go up to the next level, then you've really got to say, well, are these the words that people understand? Maybe they're not. And in the UK, sometimes there are government advisors, and they're fully familiar with these issues, but sometimes government ministers say, well, we don't really want to know about ecosystem services, just put it in things we understand. And we say, well, that is pretty simple, but however, one's got to tailor the audience, tailor the message to meet the audience. Finally, when we come to the general public, that is to a large degree out of our hands. We can produce press releases, whether or not anyone takes any notice of them. We can be interviewed, whether or not people record what we say correctly, or we get tongue-tied and really make a mess of it. But for the ocean acidification, it has attracted press interest. These are a couple of items actually from 2 or 3 years ago, but actually at the two extremes of either saying ocean acidification, no problem, don't bother about it, or that marine biological meltdown by the end of the century. Well, I think there's an area in between those, and that's the area that we occupy for scientific reason debate. I think we've been having that for the last couple of days. We will continue to have that for the next couple of days. And I think that's where my slides come to an end. Thank you very much.
Thank you, Phil. Does anyone have a question or a comment to Phil before we let him escape? No. Okay. If there are any questions, if you could state who you are and where you're from, because this is being live webcast. Okay. Okay, so if I could ask Jane to join us. So Jane Lubchenko, I think you all know her or know of her. She's from Oregon State University and is the ex-administrator for NOAA. So has a wealth of experience and knowledge and insight to ocean acidification and policy. Thank you, Jane.
Thanks, Carol. Hi, everybody. Thank you for that good introduction, Phil. I think you got us off to a great start. I'm not using any slides. I'm just going to talk. So can everybody hear me? I think we're good. Okay. So it's a great pleasure for me to be here. And I just want to say what a treat it is to see many of you again. And I'm looking forward to meet many of those people that are here that I don't know. Much of the meeting will very appropriately focus on the immediate subject matter of the meeting, which is the observing network and research, both the kind of monitoring that needs to be done, but as Phil noted, the impacts, and all of that is sort of wrapped into, I think, the agenda that we have. I want to spend the brief few minutes that I have with you focusing on a broader context, somewhat in a complementary fashion to that of Phil. The reason that I'm doing that is that based on my experiences at NOAA, I have come to really appreciate the importance not only of the bottom level of reality of inception that Phil was talking about, the OA scientists, but of the 3 tiers above that, other scientists, government funders, and politicians, and the general public. And I think that it is really incumbent upon the scientists that are working on this, the networks that we are designing, to not just know that those other levels of reality are out there and are important, but to more actively incorporate thinking about what do they need to know, how can we be helpful in sharing information in the broader context as we are designing research, designing networks, designing the day and data activities that we are engaged in. And I say that in part because far too many scientists think that public communication, communication to policymakers, is something that happens sort of at the end of a research project. We're going to focus on the research, we're going to do the research, and then at the very end, oh yeah, we have to figure out how to communicate it. And I think that these different levels of reality, if you will, are much more interdigitated, much more integrated than we often appreciate. If there is to be utilization of information that you all provide, if there's going to be funding for the kind of research activities and monitoring activities that everybody needs, there has to be much greater public and political awareness of the issue itself and the consequences and the so what and what are the opportunities for doing something about it. And that, I think, is easy for everybody to say, yeah, that's true, but that's somebody else's challenge. That's somebody else's issue. And from the experiences that I have had in Washington, D.C., working at the national level, but also international and state level, I think it's really, really important for there to be much more focus on this broader need for communication and on not necessarily everybody in this room being more involved, but in pairing with, for example, transboundary organizations earlier on in the process. Individuals and institutions that appreciate the science, that respect the science, but that are good at communicating scientific information to the broader world. Not again at the tail end, but as part and parcel of research programs. So some of you are already doing that, and all I'm flagging is the need to have that be done in a more conscious way and in a way that is moving toward addressing the ultimate solution to the problem, multiple ultimate solutions, reducing carbon emissions, but also adaptation. So let me take a step back and simply say, I think that we should all be really excited and proud with the incredible progress in our understanding that has been made about ocean acidification. I can remember 2005 when the very first report that I was aware of, the Royal Society report on ocean acidification, came out. Virtually nobody was thinking about it, talking about it, other than a very few individuals. And there has been now, I think, just an explosion of knowledge. It's actually really, really incredible. So much so that there's now almost a cacophony of acronyms and organizations and people and projects. And so a meeting like this is particularly timely to help integrate those efforts that are underway and to design, okay, how are we going to really collaborate? How are we going to focus on the things that are most important to do? How can we integrate that with other existing efforts so we're not just reinventing the wheel? So first and foremost, kudos to the community for the incredible work that has been done. And for the organizers of this workshop, it's really timely and it's important. I mentioned the cacophony of research efforts. I think that one thing that should be sobering to all of you is the fact that many of the discussions that are taking place about geoengineering to address climate change, many of those discussions by scientists as well as by politicians are taking place in the absence of any discussion about ocean acidification. And many of the geoengineering solutions that people are putting forward would do nothing to address ocean acidification. So I use that simply as a reminder of the challenge that is out there to communicate with other scientists about this issue, as well as government and public organizations, NGOs that are working on climate change. There's relatively little action on the political front, and I think all those are really necessary to address the problem that ocean acidification poses. So my perspectives in this are simply as a recent public servant, having spent 4 years in Washington, D.C., I'm well aware of, in particular in the United States, the intense politicization of climate science. I'm painfully aware of some of the budget challenges that are facing federal agencies, especially, or certainly in the United States, but I know that that's true in many other countries as well. I have the perhaps dubious honor of being, as far as I know, the only scientist to have done an OA demonstration as part of a congressional testimony, which was a very interesting experience because in the United States, when you do congressional testimony, it's a very cut and dried process that's very almost ritualized. You give your testimony ahead of time in writing. The members of the committee and their staff know what you're going to say. So they don't listen to a word when you're talking typically, and then they have questions that are sort of pro forma that some staff member has written. And because my ocean acidification demo was not something they could read about or see about ahead of time, all members of the committee were just glued on what I was doing, not understanding it. Most of them had never heard of this topic before. And I think that if nothing else, it highlights the importance of presenting information in different ways that might resonate in a different way with various audiences. I also have to say that I am deeply appreciative of the NOAA team, the NOAA scientists and the researchers, others at NOAA who have been working so diligently in providing leadership on ocean acidification. A number of them are here, but I miss you guys. I miss our mission. I don't miss the craziness of Washington, but I'm really deeply appreciative and very supportive of all that you do under sometimes very challenging circumstances. So to move to just very briefly the broader context, I want to start with something that might surprise you, and that is that ocean acidification, I think many still think of as a chemical issue. It's a chemical problem. Most of you are well aware of the need for incorporation of biology into that. It's not just chemistry, it's chemistry plus biology. But it's not just chemistry plus biology, it's chemistry plus biology plus ecology. Because the indirect effects that we're looking at and the impacts on ecosystem service delivery are ecological, not just biological. But the challenges are more than that because, especially if one focuses on ecosystem services, it's that connection to people. The political, the economic, and the social consequences of ocean acidification are every bit as much of the problem as is understanding the chemistry, understanding the biology, understanding the ecology. So I'm suggesting that we think about this in sort of a nested sense. And there has been incredible growth in the coupling of chemistry and biology and ecology. It needs to be more integrated than it is. But I think the challenge is even greater than that because it's the incorporation of the social sciences as well. Now, the more progress that we make in understanding the science, the greater the communication challenge. And so I'm going to toss this to all of you as something to be aware of and to think about in the context of this workshop. The very findings that really get us excited are ones that make it even more challenging to communicate simply to non-scientists. We know that OA changes are not uniform in space. We know that there are multiple pathways for impacts. We know that impacts vary by species. We know that there are direct as well as indirect impacts. OA interacts with other stressors, temperature, nutrient pollution. We know that it's not just about pH, that aragonite saturation state is equally important, or is even more important in many regards. But so too are other changes in ocean chemistry. So those are the kinds of things that really excite us and are some of the findings that have been elucidated over the last decade or so. But they are also the kinds of information that make it difficult to translate cool science into understandable information for non-scientists. And one of our collective challenges, I believe, is to learn to become bilingual, where we are able to talk the language of science, the technical, jargon-laden language, but also able to convert that into something that's understandable but accurate. And that's actually not an easy thing to do. So the communication needs, I think, that are out there include simple language, good analogies, appropriate icons, charismatic, eloquent, and credible spokespeople. And that should include, but shouldn't be limited to scientists. Shellfish growers, fishermen, recreational fishermen, community leaders, politicians are some of the other spokespeople that need to be entrained into this communication. Consensus statements from scientists with specific target audiences and a strategy in mind. sustained communication efforts that incorporate those, and inclusion of not just what the problem is, but the so what and what can I do. Those are some of the key elements of the communication challenge that I see that are out there. Many of you will be focused on different aspects, different topics within the workshop, working toward the goal of the end report. The workshop outcomes, I think, also need to be seen in the context of the reality that we can't fund everything that everybody would like to do, and so there have to be priorities. What are the criteria that are appropriate to setting those priorities? And I would suggest 3 to you. One is, what will provide the greatest scientific insight in the most efficient way? So that means, for example, not reinventing the wheel. If we can tap into the carbon observing network, lots more bang for the buck there. Secondly, what will provide the best guidance on mitigation and adaptation strategies? And thirdly, what will provide the best case for enhancing public awareness and public action, political action, for both reducing carbon emissions and adaptation? So those 3 criteria, I think, would be very useful to keep in mind as we're working toward identifying priorities for incorporation into a network, as well as seeking funding for those. Again, it's a pleasure to be here. I look forward to learning a lot and talking with many of you during the session, and thanks for your attention.
Thank you very much, Jane, for very insightful comments. It's a great opportunity for questions. Does anyone have a burning question for Jane? I have one. Jane, use it.
Microphone on.
Yeah. You can say you don't want to answer it if you like, but we've looked at the different CO2 scenarios for atmospheric emissions, and we've got the worst case one going up there, and we know what that's going to do. We can predict what's going to happen to the ocean chemistry, and then we've got some guesswork about how that's going to impact species, ecosystems, possibly humans. The message is really strong, but how can we really get the policymakers to listen in their time frames? Because we're kind of running out of time, as you said.
Yep.
You know, apart from communicating better, like one country is going to have to make a stand at some time, and in my mind it's either China or the US. So is there hope there for action on acidification, and then with that comes action on climate change? So difficult question.
Yep. So one of the reasons I'm really focused on communication of OA is the need that I sense to have much broader appreciation for the existence of the problem, but also engendering political will to help address the problem. And I think more and more Americans are asking questions about climate change now because of much of the extreme weather that we've been seeing in the United States. In the last 4 years, we've had the most extreme weather of any 4-year period in U.S. history since records began. So I think there is increased public awareness. For far too long, too many people have thought that climate change was something that was way far in the distance, or maybe some remote part of the world, maybe affecting polar bears, and that's about the level of their understanding. And the more they appreciate that maybe it is affecting them, the more I think there is going to be some interest in doing something about it. Now, there has to be a huge hurdle to overcome because of the very effective doubt that's been sowed by naysayers around climate change. But OA is a fresh issue and a fresh opportunity to have those discussions. And so connecting it to the so what, connecting it to shellfish growers, to fisheries, to things that, for which there is credible information. I'm not saying, stretch what we know. We have to be, squeaky clean in terms of paying attention to what we can actually justify. But having that awareness and connecting those dots for people, I think, is needed. The good news, I think, is that President Obama is engaged in serious discussions with the Chinese on a series of issues that are directly related to climate change. And the agreement that the leaders of the two countries came to recently to look seriously at HFCs, hydrofluorocarbons, is, I think, a step in the right direction. And there are lots of other discussions underway about addressing climate change, because the Chinese are appreciating how much of a human health issue that is for them. So I think it is still incredibly challenging. There's no guarantee that we're going to be able to reduce emissions fast enough to avoid really, really serious problems. But I also appreciate how nonlinear social change can be, and that once we reach a tipping point, we can have very, very rapid change. And so I think everything that can be done to reach that tipping point should be part of what we are all concerned about if we care about this issue.
And thank you. And perhaps the iconic species should be the human species.
Yes.
That would be a novelty. Instead of the polar bear, it's us. So anyway. Okay, thank you very much, Jane. Darius? Our next speaker is Darius Campbell, who just in the last year moved from DEFRA climate change, and prior to that you were DEFRA Marine, and he played a big role in making sure that there was funding there, co-funding from DEFRA for the UK Ocean Acidification Programme. So another UK hero. But Darius is now the Executive Secretary of the OSPAR, the Oslo-Paris Commission. Thank you.
Yeah. Okay, thank you very much. Thank you very much for that introduction, Carol. I'm here to talk about OSPAR, which is a regional sea convention, and I think really just to talk a little bit about how policy needs to be informed by science. It's really just to pick up some of the points actually being made by Phil and Jane in the discussions already, and I hope that there'll be a lot of half-truths and misinformation from my side, but I was thinking maybe you could provide me with some of the answers, so that's the aim anyway. Does it work? Yes. OSPAR's vision is basically to have a Northeast Atlantic system that's clean, that works well. It's basically having a healthy ocean that can be a functioning ecosystem, and of course sustainably used, so that means that humans have a role within it as well. And I guess the question for me in this meeting at least is how will ocean acidification affect that? You know, how much will it affect it? What will happen, et cetera, et cetera. So those are the sort of questions that are there in front of me. Now, just to give a little bit of information about the OSPAR Commission, basically it's a grouping of 16 contracting parties. There's the long list you can see. And these countries bordering the Northeast Atlantic are getting together to make policy decisions and assess the state of the marine environment together and work together basically to achieve that vision. And the way that OSPAR works is it really just works by people coming together and talking about the issues and coming to common decisions. And when they don't actually make decisions, those are binding, but also the OSPAR contracting parties can make recommendations and less binding things, but it's a way of working together. And it's also a way of joining up policy and science together. So OSPAR has a very strong element of working on science and assessment in the North East Atlantic. But none of this is done by us, the Secretariat. It's done by the contracting parties. They're the ones that lead the work together. Various individual countries take on the leadership of a particular activity and work together to develop the ideas and the policies. And that's really essential for the way that OSPAR works. So it's embedded and led by its contracting parties rather than us as a Secretariat being some kind of lobbying organisation with our contracting parties. And you can see also from that slide, that's the sort of area it covers. And even just discussing with some Italian colleagues today at lunch, it made me realise how much we're talking about very different ecosystems in the different sea basins of the North Atlantic. So the North Sea, quite enclosed and very different from the open Atlantic, or thinking about the Arctic and its specific characteristics and sensitivities. So very big differences and big areas to cover. And the convention has sort of fairly clear objectives. I've listed those up there. And that's, again, thinking about how it can work together to deal with pollution, to deal with human activities, and think about restoration where there's been damage. And the guiding principles, again, I think things that most people are familiar with, precautionary principle, etc. But the ecosystem, again, we try and embed the ecosystem approach in everything we do, but we're at the very, very early stages of that, I'm sure, in that we really don't understand a lot of the interactions between different components of the ecosystem. And then thinking about ocean acidification, again, what a complex thing that is to build into that ecosystem approach. But again, that's the way the convention is structured, that it should focus on that. And other sides of it, such as best available techniques, etc. That's much more the sort of technical side that we have with industry and things like that. OSPAR's been basically going since the 1970s, but in the 1990s it joined together its sort of elements that worked on dumping and pollution, and then in 1996 it focused much more bringing in biodiversity into its activities. And through that work, over the years there's been really effective action in reducing persistent organic pollution, mercury, things such as the stuff that comes from ships' bottoms in terms of anti-fouling agents. All those sort of things has been very effective action with all the contracting parties making real changes in the Northeast Atlantic. Biodiversity is a much newer area for OSPAR, but again, it's starting to make progress in terms of that, making decisions about protecting particular species. And the way that OSPAR works is it has these various committees which I've listed. So one committee focusing, when I say committee, it's actually a group of contracting parties and maybe some industry people as well. One focusing on oil and gas and dealing with the pollution from that, one dealing with radioactive pollution, one dealing on all these sort of things like organic pollutants. The Biodiversity Committee now making progress in terms of thinking about particular species to protect, and then another committee working on impacts of human activity. And those together have worked in terms of their competence, but OSPAR also works with other organisations such as the Fisheries Commission of the North East Atlantic, NIAFC, where they have competence for fisheries. OSPAR works together with them. And one of the things that in the biodiversity field OSPAR's done more recently is working with its contracting parties in terms of marine protected areas. So both within national waters and within areas beyond national jurisdiction, there are now OSPAR, a sort of network of OSPAR marine protected areas. And these again focus on particularly sensitive habitats or ecosystems. And again, what will ocean acidification do for these areas? What will we need to think about new things to protect, or about moving the borders of these areas if things change? So again, challenges for us as we think about those. In 2010, OSPAR had its big ministerial meeting that has very infrequently, and that developed the North East Atlantic Environment Strategy. And one element of that was, again, focusing on climate change issues and acidification issues. And the ministers, again, really highlighted that this is an important issue that OSPAR needed to tackle, and therefore that side of things needs to be developed within the OSPAR process. And underlying that information that was discussed by the ministers was an OSPAR 2009 assessment of climate change and ocean acidification. And that sort of just highlighted the fact that there was already evident change in the Northeast Atlantic, but also highlighted the fact that there was a wide range of impacts, and these needed to be understood, both the chemical and the physical impacts, and then thinking about the subsequent impacts on biodiversity. And again, you've already mentioned some of these in some of the discussions that have gone on here, but it's something that is, again, complex, and we need to understand the links. And understanding both the rate and magnitude, again, things that we need to understand, you know, what will happen in terms of the Atlantic circulation, what will happen in terms of ice extent, and all these, and the interactions, again, with fresh water. Thinking about the direction of change, again, something that in some cases we're not so clear about, such as the uptake of carbon dioxide by the seas. And thinking about this issue about local impacts. So again, we have very different sea basins within the Northeast Atlantic. Well, how will these different effects happen at those levels? And then, of course, we are very much interested in the impacts on biota, and on plankton, on the seabed, on benthic organisms, etc., etc. And stratification, again, is one important aspect of the Northeast Atlantic ecosystems that will be of interest. So again, lots of issues were raised in that 2009 assessment and informed the ministers in their discussions. And OSPAR, through its Northeast Atlantic strategy, wanted to highlight that through collective actions of its contracting parties, it could address things on mitigation and adaptation. So mitigation, thinking about blue carbon and things like that, and also thinking about what might happen in the end if people did start turning to ocean fertilization and geoengineering activities. And then thinking about adaptation, thinking about what OSPAR could do in terms of its work of its contracting parties together, in terms of research and monitoring and assessment, thinking about what its contracting parties might do about mariculture, thinking about early warning systems within the marine environment and what OSPAR might want to do in terms of assessing that. And then I guess core to OSPAR's activities is thinking about resilience, because really most of what OSPAR does about reducing pollution, about marine protected areas, et cetera, is about increasing the resilience of the ecosystem to new pressures. And of course, one of those new pressures will be ocean acidification. And then one element as well of OSPAR's Northeast Atlantic strategy is thinking about working with others in terms of developing countries and helping technology exchange or information exchange with other organizations, such as another regional sea in more southerly waters on the Atlantic coast. And OSPAR also works on the international side, so obviously there's a strong EU element with our contracting parties, so OSPAR is working in the context of directives on climate change and on carbon capture and storage and things like that. And also working with the United Nations General Assembly processes and intersessional processes, which again are looking at ocean acidification this summer. And then working with the Convention on Biological Diversity as well, as they look at the sort of systematic approach in looking at the impacts of ocean acidification on ecosystem services, etc. So those sort of international processes is something that OSPAR, through its contracting parties, can work with. Again, the London Convention on Dumping is another area which is looking at geoengineering and carbon capture and storage. And of course, being here at this network as well is sort of one part of that process. I think one thing I wanted to sort of highlight in particular was OSPAR's work on human impacts and on the marine environment. And that work has really looked very carefully at what national adaptation programs are doing now within the contracting parties. And I guess my personal observation on that is that national adaptation programs are looking at things like flooding, coastal flooding, things like that, maybe a little bit on fisheries, but they really aren't thinking much beyond that. And so I think that's a big gap. And in terms of a policy-oriented discussion, how do we then deal with the uncertainties that Phil was talking about? Having done a national adaptation program myself in the early stages in the UK, I think one of the things we really need to understand is how to do risk-based decision-making, so that in the face of uncertainty, how do we focus on those things that we do know a little bit about, those things that are win-win activities, so that by, say, increasing resilience in the ecosystem for other reasons, you're also helping with ocean acidification issues. Or what are the things that we need to actually put aside for now until we have more understanding later. So that idea about focusing on things for different timescales and for different reasons is really important in adaptation. And so again, OSPAR needs to understand that process for ocean acidification. And again, the information that comes from science is really important in that. This slide I just put in because I like little fish, actually. But that uncertainty is really important. And OSPAR is trying to address at least some of that now by starting a process where it's trying to monitor and assess the changes in ocean acidification in its waters. So at least it has some kind of understanding about what's happening within the OSPAR waters and from a regional perspective. And so OSPAR, it has these processes called joint assessment and monitoring programs, and common monitoring programs. And this is about getting its contracting parties to start looking at measuring things in similar ways so that we can start assessing things over the wider area rather than disparate national approaches. And again, part of what you're doing is part of that process about harmonizing approaches so that we can understand how those things work together. So OSPAR is, again, very active in that process, and what we've got at the moment is a process where we have worked with ICES and OSPAR in a joint group to look at the issues that OSPAR needs to monitor and to start developing common monitoring processes within OSPAR. I think I'll just sort of come to sort of final thing about thinking about, again, the impacts that we need to think about within OSPAR. Some of the things that I was certainly thinking about in preparing for this was thinking about the effects such as wider climate change impacts such as slowed circulation or stratification and how that interacts with acidification, thinking about the chemical aspects of, say, changes in freshwater input and solubility. And that, for our Hazardous Substances Committee, is really important because they're thinking about pollutants and how they might be more soluble or how they might be increased in circulation because of climate change. So those things are really important from that perspective. Then looking at the Radioactivity Committee, again, the same thing, they're thinking about solubilization. For the Biodiversity Committee, they're thinking about the knock-on impacts of climate change and ocean acidification on ecosystems. So again, for them, it's central to understand what ocean acidification is doing. And then for the Human Activity Committee, they're looking at carbon capture and storage. Well, they're interested in modeling what the impacts are of carbon leakage. So that might be of interest and of linkage. But then thinking about, again, wider human activities and how they might interact with ocean acidification in terms of sensitivity. So there's a whole load of stuff in our different activities that we need to know, but I guess we feel at the moment we are very early stages, and I certainly see that in the contracting parties. They don't seem to be quite ready to make a next step in understanding what they need to do, and that's because they need more information, certainly at this stage, and that's their perception. So I think that's all I need to say. I've had a red flag waved at me several times, so I've got to stop there. Thank you.
Thank you, Darius. Do we have a question from the audience? If you could state your name and affiliation, please.
Yes, I'm Rick Monikoff. I work at...
Oh, sorry. Could you also grab a microphone? It's because we're being recorded.
I'm Rick Vonnenkopf. I work at a NOAA lab in Miami. This is a bit of a general question, I think, to think about in the meeting as well. You mentioned in one of the main objectives of OSPAR was prevent and eliminate pollution. Does OSPAR consider fossil fuel-derived CO2 a pollutant?
OSPAR has sort of fairly clear competences about areas that it can regulate and it can't. So although effectively that is a pollutant, it's not an area that it regulates, but it would try and speak to those who regulate and say, this is a major problem. So we would certainly want to highlight the issue.
Any other questions? I have a very short question. How do you think OSPAR can encourage the member states to monitor and observe ocean acidification? And if it can, is it a good role model to perhaps bridge the gap over to the other side of the Atlantic? How restricted is OSPAR? Is it a good role model? And how do you actually really make the member states follow guidance that hopefully this group will develop.
Well, I won't presume to be a role model to anybody else at all. OSPAR is very much, the Secretariat, we're just servants of the contracting parties. What we're trying to do is facilitate a process where contracting parties see it's in their interest to do something together. And I think in practice what's happened over the long experience of OSPAR is it takes a few contracting parties to be really enthusiastic about an idea, and then the others join in with them. And I think, especially now actually, where resources are very restricted, I think there's a stronger and stronger driver for people to work together and to actually do this stuff together. It actually saves money and time if people are doing together. And I think OSPAR has a strong enough history to know that where it has done that in the past, it has been very effective on specific issues. But I think ocean acidification is certainly a new one and a new challenge, and certainly I, as Executive Secretary, will carry on pushing the agenda with my contracting parties so that they see it as an important issue.
Excellent. Thank you. We look forward to your contribution to the rest of the workshop then.
Thank you.
Thank you. Okay, our next speaker, if he can come up, please. If you could swap dog collars, that would be great. Phil, could you do the loading? Thank you. I'd like to welcome and thank Maciej Telszewski, the Director of the International Ocean Carbon Coordination Project.
Yep.
Thank you.
Thank you, Carol. It is Maciej Telszewski. You tried hard and it worked. It's a pleasure to be here for me personally, and it's a pleasure for IOCCP to be actively involved in the observing network for ocean acidification. And I think we'll have a slight change of gears now over the next 15 minutes or maybe 17 minutes. I'll try to propose a couple of tools that I suggest we use during the phasing in and implementing the ocean observing network for ocean acidification. These are the framework for ocean observing, and many of you might be familiar with it. I'll try to tell you what is it all about and why we think it should be used for every observing network, no matter how big or how small. And the second subject will be the ship-based time series, which I think have a mutual benefit for both communities if we try to utilize those platforms for OA observing. Before that, though, I'll try to briefly tell you what IOCCP is, because you might not heard of it. So, International Ocean Carbon Coordination Project is the latest child in a long sequence of IOCs and SCORES collaborative agreements that is dealing with coordination and communicating ocean carbon observations. And observation is the key here. We mainly focus on observations. And as I said, IOC was actually funded on the need to coordinate and understand ocean carbon, and was joined by SCORE very soon to create a advisory body for ocean carbon observations. This body was changed names several times over the 50 years. And in 2002, as you can see, in 2002, SCORE and IOC decided that they will call it a pilot project with a secretarial support and see whether the community really needs something bigger than just a panel of PIs. And it actually worked very well, and in 2005 both organizations decided that this is a standing project, that the reality has changed, and ocean carbon community needs this standing body to help them talk to each other and help them implement whatever the issues of the day are. Because I only have 15 minutes, you'll have to look at the website to find out more about your specific areas of interest. But what we are about 15 people, more or less, 10 to 15 people, experts in fields named here, and ocean acidification. We've been lucky to have Dick Feely on our panel. He joined recently. For other fields, we try to change those people every 6 years, and by having these 15 people, we try to encompass the issues that deal with coordination of data collection, but also data management, practices, best practices, etc., etc. So in terms of ocean acidification, there are several bodies, as has been mentioned already, that will be talking about OA. IOCCP has taken responsibility for providing its assets, so providing the observational networks that are under our coordination, so surface ocean CO2 observation, ocean interior observations, and data related to those, also some time series activities, and all these are invaluable assets for OA monitoring, and we will try to coordinate between the two communities to help the Global Ocean Acidification Observing Network work efficiently. So that's IOCCP, and now the website is just changed recently. You can go and have a look, join the email list to find out what we're doing and when. Okay, framework for ocean observing. It's been around the idea has been around for 4 years now, since 2009. During the Ocean Ops meeting, about 600 people from more or less every single organization that has to do with ocean observing decided that there needs to be a change in the global ocean observing system, in the way it's being done. Mainly, the challenge was to combine the physical, the chemical, and biological, mainly independent observing networks into one entity under some sort of a framework that people can talk the same language. As you know, we don't, but that's the framework's process that we hope, when implemented, will help us combine all these efforts in those three regions. So what they did, they took the systems approach, as it's called. There's an input to the system, which is a requirement. The requirement being climate change, be it a societal issue, regional issue, or global issue. Then there is the process, and this is the observation. So you need to observe to answer the question in the requirement. And then there is an output, which is your data or synthesis product. Now, this is more or less how it looks like at the moment. So there is a whole bunch of largely independent observing networks. They usually submit their data to largely independent data centers. And so the data and analysis, as we've heard this 2 talks ago, they not necessarily provide information to the policymakers, or the information they could provide. It's not efficient enough. So what the framework is proposing is that here the requirements are being set based on scientific and societal issues. So we actually want to have society tell us, society via policymakers, but also via all other parts of the public, what are the requirements and what is it that we want to know. Then we will decide what to measure, and the whole framework of ocean observing is being centered around essential ocean variables. And I think it's perfect time for OA observing network to jump on the wagon, because these essential ocean variables are being developed, and basically we aim at 10-15 variables that will answer most of the requirements we might have at the moment, and some of them obviously will be PA related. And once we have the outputs, which is the data and information products, synthesis products, we assess their impact on the requirement, and we can then change the requirement or adjust the requirement according to the impact the output from the system has. And I said that the whole idea is centered around the essential ocean variables, EOVs. So it's not a new idea. The essential climate variables were around for a while. Then WMO came up with essential variables for weather. GOA-ON is trying to implement the essential biodiversity variables, but they are mainly terrestrial. And obviously, then the essential ocean variables is what we are trying to promote. And the idea is that we don't focus on the platform or the sensor or the technological capability. We focus on the variable that we need to measure. And in the process, we come up to the stage where we actually can measure particular variable at needed resolution, at needed accuracy, but we don't limit ourselves by our technological or financial restrictions over time. Now, obviously, there's many variables that we would want to know, but we don't have the technology or money, as I said, to do that. And so there is a process that's assessing the readiness level of certain parameter. And it's a simplified version, and in the full document, which, by the way, is available from our website, but also hard copies are on the registration table. There are 9 levels from idea until sustainable. So, and it goes for requirement, for observations, or for data management. So even the requirement can be in a very early stage, and we are not sure whether this is actually what we want to know. And through the framework process, we assess what needs to be done to develop this requirement, to put it into the pilot phase, and finally, if it matures and if it's globally agreed that certain requirement will help us, our society and our science, will implement it into the observation phase, and the same process again. So we assess where are we with observing certain parameter until we have the sustainable system that can be implemented globally, and then data. And there's one example I can think of, which is SOCAT. You've heard about it this morning, those of you who were there, where there was an idea, then there was a process of collecting data, and then doing the data management. And now there is a product, and we'll see what impact this product will have, and whether there will be a need to measure, for example, other parameters, because of what SOCAT gives is perhaps fantastic, but not answering all the questions. So this assessment is where we also have an opportunity to tell our funders that the requirement, in order to answer certain questions or to meet the requirements, we need to develop certain technologies because we are not able to measure parameters. And it's the opportunity for sensor developments, basically, and technology development, as well as research, because even though this is supposed to be an operational oceanography kind of thinking or systems thinking, without interest in research involved, we will not get PIs involved. So there needs to be a field, a lot of space for research, basically, which I think this assessment of readiness gives. Okay, so this is more or less what we have now. The requirement is climate and weather, and as you know, it's changed, and it's changed to more or less something like that. So we have regional priorities, we have fisheries, we have real-time services, and probably many more. And the good thing about the framework for ocean observing is that the requirements can change, they can be added and can be excluded depending on the needs of the society and scientific community. And all it will mean basically is that our EOVs will either change or we'll think about EOVs that actually answer more than one requirement, because obviously the money will be the issue, is always the issue. And then if you have more requirements, more observations, you probably have more data products that go back to square one, where we assess whether the impact of this action, of this observation was what we wanted. And for OA, probably a lot of it will be done via the carbon measurements, but I'm not a specialist outside the carbon, so I can think of a few outside, which I'm sure can be easily applied to the framework of ocean observing. So when these people worked for 3 years, 2009, 2011, they had these high-level objectives in mind. So it's not that we want to change the observing community. It's not that we want to change the way particular observing networks work. We want to try and guide them towards one way of dealing with things, one lingo, for example, which is often the problem. Technologically and especially data streams, there's a very interesting talk from BODC about DOIs. It's a problem for every single community now, And we need to work together to actually come up with a way to deal with DOIs and with data acknowledgement. Then promote collaborative alignment of existing networks and also build on the experiences. A lot of it was built on the experiences of physical oceanographers because they've been operational for quite a while longer than others. Perhaps the biogeochemists are a little less experienced, and biologists have most to learn in terms of this model thinking, this system thinking. We don't think that we'll be able to support financially the actual networks, but support the self-funding and self-managing elements by promoting the idea of collaboration and including them in the larger scheme of things. And deliver fit-for-purpose coastal and open ocean integrated observing system. So the purpose is to have the requirement, to meet the requirement, and that's why it's dynamic, in a sense that as soon as a requirement changes, the whole system changes, and the EOV that's needed to be measured changes as well, in that sense. Benefits to us, observing community mainly, that's who I think I'm talking to. So focus on variables allows innovation, that's what I said. If we really want to measure certain variable because it's needed for a certain requirement, we will do that in a framework of 10 years maybe. Maybe there will be time involved and money involved, but instead of focusing on platforms, this is allowing for innovation. Selling utility because we are actually taking our requirements from the society and from policymakers. We actually have this straight path back. This communication can go two ways, I hope, at the end of the process. Maybe OceanOps 2019 will be the first example where we actually deliver on the requirements set by the community. I said about learning from other observing networks. Remove duplication. There's a lot of work done coastally by national programs. That's duplicated over borders. That's duplicated in terms of time and space. And I think that being in the framework for ocean observing, we might be able to save money to use the same platforms, join efforts, and join human resources as well. Okay, and the final slide on the FOO. This is the way that the governance structure was envisaged. So at the bottom, which I think is the most important part of the whole structure, is the observing networks. So the Global Ocean Observing Network for OA would be one of those. And because there are three rather different realms, physics, carbon, and biogeochemistry and biology, the framework decided that there will be three panels, one for each of these subjects, and IOCCP was asked to lead the carbon and biogeochemistry, and OA obviously falls into that box. So IOCCP will be trying to include OA EOVs into the framework for ocean observing. And then the GOOS steering committee, which becomes the framework steering committee, so the Global Ocean Observing System, will be discussing the high-level issues within the UN, intergovernmentally and internationally, as well as will bring the coordination platform for international parts of the network. And as for us, we have a little plan for the next year or 10 months actually by now. First, this is happening right now. We need to look out there. What is there that people want to measure basically, and why? So this is we need to collect the available information. Then, based on these requirements that we will find, we'll consult with relevant programmatic partners on the essential ocean variables. So this is the key moment for the biogeochemistry panel to actually develop a suite of essential ocean variables for biogeochemistry. Once that's done, and the list, as you might imagine, will be as big will be the panel, so probably, I don't know, 60 variables, and we probably want to have 10 to 15 at the most. So we'll need to do the assessment and actually choose those that are the most advanced and the closest to answering to the requirements. And once that's done, we'll actually publish or at least draft a publication that will say that those X essential ocean variables for biogeochemistry are needed to answer certain requirements. And that's going to be presented, we hope, during the Ocean Sciences meeting in Hawaii in 2014. Okay, the two questions at the end of this part, and I think I'll skip the time series for now at least. So the statement, I think that Global Ocean Acidification Observing Network should be involved in this cycle, especially of the cycle of assessment of requirements and then assessment of the essential ocean variables. And it's mutual benefit to the community and to the FOO, because OA is a growing concern, and we need to be able to long-term monitor it using the variables that are closest to our answers. Now the question, how can we work, how the GOA-ON can work that it benefits from the FOO, and how FOO can benefit from the GOA-ON. And I think this is something that we will try to answer over the next 2.5 days. I can find few answers myself. I'm sure you can at the moment, but it would be great to brainstorm it for a while and try to think of the FOO as the way of implementing the Global Ocean Acidification Observing Network. And I think I will skip this part of the talk. It's a couple of slides, but I ran out of time, I guess, right? Thank you.
Thank you, Maciej. We have time for one question. Should there be one? Microphone up.
So many of the various programs that will be involved with carbon and acidification will be different in nature in that some programs will involve moorings, other programs will involve floats and gliders, other programs involve primarily cruises. When you start looking at essential ocean variables, will you try and assess where that variable is in relation to the platforms that will be available? How is that going to work?
Yes, so there is a rather complicated matrix of assessment, and that's where we really need senior PIs to work with us, and we'll actually reach out to some of you in this room very soon, because you've mentioned platforms, but there's also depths. There's few other parameters that you need to take into account when assessing whether a certain parameter is going to work or not. And this is the readiness level. If a certain parameter can only be measured from a mooring, so be it. It's on level 1 or level 2 out of 9 levels, and we will work very hard towards moving this parameter from level 2 to level 9 until it's going to be a sustained element of the observing network. So this is why I said we focus on the parameters rather than platforms, because if you focus on platforms, you get many answers for one question, whereas parameters is just one, it's just the way you measure it. The same, the technology for measuring it, and platforms and depth, etc., etc. There will be a lot to take into account before we actually agree on the EOV.
Great. So lots to discuss. Could we have your microphone, please? Okay. Our next speaker is Lena Hansen, who many of you will know.
Where's this one? Is that it?
Okay, it's Velcro. Okay. Yep. From EPICA. She was the EPICA project officer, and she's now the project officer for the Ocean Acidification International Coordination Centre at the IAEA. So Lena, thank you.
Thank you. So I will present to you a very quick overview of the Ocean Acidification International Coordination Centre. So this new, quite new project that you might not have heard so much about yet. So it's a project of the International Atomic Energy Agency, the IAEA, and it is based at the IAEA Environment Laboratories in Monaco. So just a few words on the background of this project. So the OASCC was launched as a response to a recommendation from the scientific community and the science user community. So through the SOLAS-IMBER Ocean Acidification Working Group and the Ocean Acidification International Reference User Group, the RUG, who identified the need for an international coordination project on ocean acidification, and also in response to increasing concerns of IAEA member states about this emerging environmental threat, and to recent developments in United Nations context. So, for example, ocean acidification has been mentioned in several recent documents. For example, the outcome document of Rio Plus 20 conference on sustainable development last summer. So that is kind of the context and the background. And the three keywords to remember about this project, the OASCC, is communicate, promote, and facilitate. And so this is the OASCC. It's about a number of international activities that are facilitated by this project. So I will go into those quickly later on to give you a flavor of what the project activities look like. And the end users are the scientific community, but also science users. The functioning of this project, so it was launched a year ago, fully operational this year, and it has a planned duration of 3 years. So there is a project team composed of a full-time project officer, that's myself. There will be a project assistant, so the recruitment is ongoing. We have interviews actually next week for this position. And it will be on assistance on the communication parts of the project. The responsible IAEA officer is Michel Warneau, program manager of this project, and we work very closely together with the OASCC scientific coordinator, who is Jim Orr, and a data curator who is based at Xiamen University in China. So it's taking care of the data management activity of the project, which I will briefly also mention in some other slides. So the project is advised by an advisory board with membership of key institutions and leading scientists in the field. And the first meeting of this group was held in May. So the project is supported through the IAEA Peaceful Uses Initiative and through direct and in-kind contributions from member states and research projects on OA. And I will not have the time to go into this in detail, but you can see that it is international effort, and you will recognize, of course, the many projects on ocean acidification that have been instrumental and is still instrumental in the implementation of this project. So the total budget is around $2 million for 3 years, and about half in cash and half in in-kind contributions from the OASCC partners. So I will not have time to get into the activities to any larger extent, but more information are available on our website. I will give a link to that on a slide later on. So there are 11 activities that the OASCC will try to facilitate and promote. And on each slide, you will note that there are focal points, and these are the experts in each that help implement each activity. So I think many of those activities can be relevant to the GOA-ON, and of course the first one is the GOA-ON activity. It's the Global Observation Network led by Dick Feely and Libby Jewett. So the goal is to help create and build this global observing network. The approach to reach this is to promote workshops to unite the community, so the GOA-ON workshops, and the outcome projects such as reports, guidelines. The second activity is called Joint Platforms and Facilities. So this is to encourage international collaboration through support to researchers to travel to predefined platforms and facilities. This is something that will be announced shortly on the OASCC website, and it's going to be implemented in the next 2 years or so. The third activity is this very challenging one of collaboration, facilitate collaboration between natural and social sciences. It has already been a few, how do you say, yeah, there have been already 2 workshops on the economics of ocean acidification, but the idea with this activity is to broaden the scope and to include social sciences other than economics. So this is something that is planned for next year, perhaps back to back with this economic workshop. The fourth activity is quite similar to the one I mentioned before, supporting a certain number of scientists, in this case early career scientists, to visit pre-identified host laboratories. So this is to learn a specific technique or to increase collaboration. So this is also something that will be implemented in the next 2 years, and more information about that will be up soon again. Into comparison exercises. So this is an activity that has already started. The first product of this is, you will hear more about it tomorrow. Jim will speak about this. It's a comparison of carbonate chemistry software packages in cooperation with IOCCP. This was done. And there will be comparison of boron isotope measurements in 2015, perhaps others. Number 6 is joint experiments. So again, it's cooperation and very closely linked, of course, to the previous activities on funding people to go to experiments and platforms. And the key tool for this will also be the website, where we'll list existing opportunities. Best practices, so this can also be of interest, of course, to this group. So this is to build on efforts that have already been developed during EPOCA, the EU project, which this guide was published in 2010. And the idea is to have a new expert workshop and see how to evolve and revise this best practices guide, perhaps to include multiple stressors. Another service we would like to provide is online access to a list of bibliographic references on OA, which would be searchable. This is in progress, and hopefully will be online in the next few months. And data management. So the data management activities, I should say, has been defined as more focused on not observational data, but on experimental data. So the approach is to continue a data compilation on the biological response, which was started through EPOCA Neurooceans. This has been resumed just recently by the data curator. And to organize a workshop with the different data curators to see how we can increase international data management and coordinate existing efforts. And there's discussions about this going on. I hope to get the occasion to discuss this a bit during this meeting as well. Capacity building is very easy. It's, of course, support training courses for newcomers into the field, and it can also perhaps be relevant, I hope, to this network. And finally, information sharing and communication. So this is to another challenging part, to get the message out, as we have heard about earlier today. So the main tools for this is, of course, the website and the news stream. The news stream is known as the former Epoca information outlet. It was transferred to the ICC this week, and the website is also available since last week, and it will be, it's work in progress, but it will be developed during the weeks and months to come. And we have, I will have put some of those leaflets up there if you want to know a bit more about the project. And we have also a close collaboration with the reference user group, who is kind of specialized to getting the message out to policymakers. And also participated in the international partnership that many of you knows about, coordinated by the UKOA and PML, the hot, sour, and breathless message that has been taken to several international fora for a long time now. So that are some of the activities. Very quickly, if you have questions, I will be happy to answer them, and I'll also be around for to discuss during the rest of the meeting and have a look at those. Thank you very much.
Thank you very much, Lina. Is there a quick question for Lina from anyone, or would you prefer to catch her over coffee? I think we have lots of time to discuss this important role. Okay, our final speaker is Paul Bungie, who is the Senior Director for the Wendy Schmidt Prize on Ocean Acidification.
Indeed.
Okay, thank you, Paul. So you've got 5 minutes.
I've got 5 minutes.
Yep.
I've got to be quick. So no slides to make it faster, hopefully. I want to thank you, Carol, and thank you, Phil, and the organizers for inviting X Prize here. I'm really, really excited to finally meet a lot of you that I've talked to on the phone and meet a whole lot more otherwise. For those of you who aren't familiar with X Prize, really quickly, we're a nonprofit organization that runs extremely large incentive competitions to create radical breakthroughs through the benefit of humanity. That quite literally means anything on the scale of $1 to $30 million prize purses for technological breakthroughs in areas associated with life sciences, education, global development, the environment, and exploration, which is largely space. So many of you have probably heard of some of our prizes, like the Ansari X Prize to send 2 people into space twice within 2 weeks using only private money. That's now Virgin Galactic, which is starting to take your checks if you have $500,000 for a flight. That also includes oceans. And I'm particularly excited because we're launching our second Oceans Prize in just a couple of months, and I'm here to help spread the word and ask for your help associated with these. Now, because we're all about these radical breakthroughs, what that really means is that we need to help focus and incentivize a broad community of innovators. Our clients, the people we serve, everything we do is about innovators and scientists like yourselves. We're not here to solve the problem, we're here to inspire and give you the tools that will allow you to do that yourselves, and then do it on a scale much larger than anything possible before, using all of the sorts of efforts we've heard about today and we'll hear about in the next couple of weeks. That also means that we incentivize technological breakthroughs, and in this case, being ocean acidification being a grand challenge, we recognize that without being able to tackle immediately the carbon dioxide problem, we need to scale back to something that is going to be that first domino to fall in addressing issues. And everything we're talking about here is exactly what we're all about. And so the next prize that we're going to be launching in September is a $2 million prize called the Wendy Schmidt Ocean Health X Prize. And it's narrowly focused on breakthrough pH sensors that will be orders of magnitude more accurate, precise, stable, radically more affordable, and radically more easier to use, as demonstration that we not only need tools to assess these sorts of things, but we need tools that can go anywhere in the world, be used by anyone, and start to integrate through the sorts of data approaches that Lina was discussing, and through the sorts of scientific assessments and analyses that all of you here are doing. Through that process, that technological breakthrough, however, doesn't produce just one thing, doesn't just produce a better pH sensor. A big part of the X Prize is the focusing of a community broadly of communities of innovators elsewhere, bringing new people into it. So folks that might be dealing with other forms of environmental observation to start thinking about how they might innovate in oceans, for instance. It's also meant to start bringing attention from the rest of the world into this, and that includes attention from people with money, investment. We'll work very hard to bring new investment dollars into this space. People from government who have influence on policy and the like. We'll work very hard to do these things. And of course, the public. Big giant, as you can imagine, big giant exciting competitions like this do have a tendency to focus the public's attention globally on a problem they may not have heard before. And that's what I'm here to ask you for, because we're here to start exciting people about these problems, but then really what we need is the community at large to be the ones who can then take it and run with it, do the sorts of things that Jane was referring to in better communications, do the types of demonstration of the value of science itself and ocean science itself in assessing, monitoring, and ultimately trying to protect our ocean environments. And so, there's really briefly, while I'm here, and I'm going to be here the next few days, I'm mostly here to learn and experience as much as I can, meet as many of you as possible, but I've got 5 things that I'd like to ask of you, if you all don't mind. Number 1, tune in on September 9th. We're going to be launching this prize, we're going to be launching in a big way, and I could use your help in sending out the message to everyone that you want, that you know. Let everybody know globally that this is happening and that we're here to try and make a big impact. Number 2, help us recruit teams. This is all about innovators from around the world, from every possible industry. I guarantee you already know some people that might be working on various sensors that would be interested in winning a few $1 million. Number 3, please become a resource. Like I said, an X Prize is not just about that technical breakthrough. It's also, we're going to be putting a lot of effort into communications and into educational activities. We want to partner with as many folks as we can and bring attention to the work that you're already doing. So please help us become a resource if you're a scientific expert, communications, you know work on related issues associated with observations or data products and the like. Please let us know. We're going to be coordinating quite a large effort throughout this. Related to that, number 4 is help us build the post-prize industry. Everything that we're talking about here in these data opportunities are not only valuable for scientific understanding, but these are potentially billions of dollars worth of data products and information services every year. We want to try and catalyze and grow the ocean services industry broadly using this, and we could use your help in doing that as well. And then number 5, please use this prize as an opportunity. Please capitalize on what we're going to be doing. We're going to be bringing a lot of attention to the issue. I care deeply about everything that you all are doing, and I want you to be able to say, if you're speaking to Parliament or Congress or somebody else, did you hear that cool X Prize thing that was in the paper the other day? That's why we need $10 million more in research funding. Use it as an opportunity to not only excite your constituencies, but use it as an opportunity to build the community more broadly and demonstrate everything that you all here in the room know about your importance, and use that as an opportunity to tell that story even more broadly to the rest of the world. So I'll be here for the rest of the week, and I'm really, really grateful for everyone that's here. Thank you all for doing what you do, and I look forward to working together.
Fantastic interest from foundations such as yours to stimulate investment and innovation within this important area of science. So I think it's kind of heartwarming to see interest from the outside, and I'm sure as a community we can share and grow together.